If A, B and C are interior angles of a triangle ABC, then we have to prove that cos of B plus C by 2 is equal to sine of A by 2. As you can see in the figure mentioned below, let's assume this is the triangle of the equation. By the angle sum of the property, we know that all the angles in a triangle equates, the sum of all the angles in a triangle equates to 180 degree. We will use this property to solve this question further. As we can see, the sum of all the angles of a triangle, that is A plus B plus C, is equal to 180 degree. Now we will take A to the other side, which will negate the value of A, which in turn gives us the expression B plus C is equal to 180 minus A. Now we will divide both the sides by 2, which will give the value this: A plus B plus C by 2 is equal to 180 minus A by 2. We will we will use the value of 2 and divide individual value on the right hand side by 2, which gives out the expression 90 minus A by 2. Now we will take cos both sides, which will give the expression cos B plus C by 2 is equal to cos 90 minus A by 2. And as we know that trigonometric functions are complementary, so cos 90 minus theta can be also written as sin theta. So we will use that property and we will get a final answer, that is cos B plus C by 2 is equal to sin A by 2.